This brings me to the last factor affecting solubility of a sparingly soluble electrolyte, which factor we are calling addition of a soluble compound containing no similar ion as those in the electrolyte. I'm going to attack this by a question. I'm going to attack this by a question. You know some sparingly soluble salts. You know some sparingly soluble salts. Which one can I think of? Which one can I think of? And I think of copper 2 carbonate. I think I can think of copper 2 carbonate or copper 2 oxalate. Let me say. Okay, calcium ethane dioate. Let me think of calcium ethane dioate. And this is how my question will go. The question says, calcium ethane dioate. You are aware this is the same as calcium oxalate. Is less soluble in ethane dioic acid. Ethane dioic acid, but more soluble in nitric acid. This is a very good question. Calcium ethane dioate is less soluble in ethane dioic acid. Ethane dioic acid is the same as oxalic acid, but very soluble in nitric acid. Explain. Such questions appear in paper 2. That question of explain the following observations. Sometimes you may be disturbed in paper 1 and you see such a question in section A, number 8. And then you see it, you say, what can I do? This question is in section A. Section A question is paper 1, I must attempt. So I always encourage students to read everything. Don't think some things are hard, because there are cases when it may appear and you have no way to run from it. So first of all, this is a two-part question. Divide the question into 2 parts and explain each part independently. The first part is that calcium ethane dioate is less soluble in ethane dioic acid. Look at that part first before you look at why it is more soluble in nitric acid. What is the formula of calcium ethane dioate? Calcium ethane dioate is calcium oxalate. It is a sparingly soluble compound. Calcium has valence 2, the ethane dioate ion has valence 2. So being a sparingly soluble compound, that is its equation for solubility. Calcium ions, ethane dioate ions. Ethane dioic acid is oxalic acid. That is its formula. For it, it is a strong electrolyte. It is very much soluble in water, giving us 2 hydrogen ions and oxalate ions. Let me hope you have already seen the effect as to why it is less, as why calcium oxalate is less soluble in oxalic acid. Mary, have you already seen the effect?
Yes, teacher.
Which effect is that?
Common ion effect.
Perfect. This is common ion effect. So why is calcium methane less soluble in oxalic acid? Begin by saying calcium oxalate is sparingly soluble in water. Write that equation. Then say oxalic acid is a strong electrolyte. Hence completely ionizes to form hydrogen ions and oxalate ions. Write that equation. Therefore, it produces oxalate ions which are common to oxalate ions in calcium oxalate. Then tell us what happens to the excess oxalate ions. So the excess oxalate ions do what? What will they react with? Muhammad, what do the excess oxalate ions react with?
Calcium ions.
Perfect. They react with calcium ions to precipitate calcium oxalate. This equation is self-balancing. So when that happens, what do you tell the examiner next? So the excess calcium ion, oxalate ions react with calcium ions to precipitate calcium oxalate. Why does that happen? Normally you forget that to restore the equilibrium, hence maintaining the value of the equilibrium constant. Maintaining the equilibrium constant. So that makes calcium methane less soluble in oxalic acid. That is the first part of the question. Now you attack the second part of the question. Why is calcium oxalate more soluble in nitric acid? This brings me to this concept that I want to emphasize here. Are we together? So we have already seen this calcium oxalate here. They're asking us why it is more soluble in nitric acid. So what happens in nitric acid? Nitric acid is a compound that has no common ion at all. There is no common ion it has with calcium oxalate. So why is there increased solubility with it? I want you to first of all understand that additional compound that has no common ion with the present compound increases its solubility. Why? Look at this. The concept here is that these hydrogen ions here are going to react with oxalate ions. When they react with the oxalate ions, they will form soluble oxalic acid. There should be 2 here. Okay. Similarly, actually, there is also another reaction here. Calcium ions are going to react with nitrate ions. But you may look, if you are in an exam, you look at one side, you may not look at both. This also forms as, okay, this is not oxalate, it's nitrate ions. Are you getting me?
Yes, teacher.
So when the calcium ions react with the nitrate ions, we shall form nitrate, calcium nitrate, which is also soluble. So you say, in presence of nitric acid, the hydrogen ions react with oxalate ions to form oxalic acid, which is a soluble compound. That reduces the concentration of oxalate ions at equilibrium, hence more calcium oxalate dissolves to restore the equilibrium, maintaining the value of equilibrium constant. Or you can say the calcium ions react with nitrate ions to form calcium nitrate, which is very soluble. Hence more calcium oxalate dissolves to restore the equilibrium, maintaining the value of the equilibrium constant. Are we together?
Yes, teacher.
Can I look at another example where there is effect of a soluble compound with no common ion? Can I look at one more example?
Yes, teacher.
Let me think of it now. Which example can we see? Which example can we see? Which example can we see? Let's look at a solution, a sparingly soluble aluminium hydroxide. Have aluminium hydroxide. You are aware it is sparingly soluble. It's formed by precipitation. So in solution, it forms aluminium ions and hydroxide ions. 3 of them. This solution, if I add a compound that has no common ion, which compound can I add here now? Which compound can I add here now? Let me add magnesium nitrate. Let me add magnesium nitrate. I'm adding magnesium nitrate. People who don't know this effect always get confused when they come across such questions. So that's the example I have. This one is tricky. It's tricky, and I expect you to ask me a question. If you don't ask that question, then I will know that there could be a problem. So when you add magnesium nitrate to a solution containing aluminium hydroxide, sparingly soluble, a saturated solution actual of aluminium hydroxide, solubility of aluminium hydroxide increases. I'm using formulae here to save space. In exams, you use words. Increases. Why does it increase? Because what do you think is the reaction that will take place here? What do you think is the reaction that will take place here?
Aluminium ions plus nitrate ions.
Very good. Aluminium ions are going to react with nitrate ions. However, there is something I've not written here. First of all, start by telling us that aluminium hydroxide is sparingly soluble. Then magnesium nitrate is a strong electrolyte. Completely ionizes to form magnesium ions and nitrate ions. So solubility of aluminium hydroxide increases because aluminium ions react with nitrate ions to form aluminium nitrate, which is soluble. This does what? This decreases the concentration of aluminium ions at equilibrium, right? Therefore, more aluminium hydroxide dissolves. Why does it dissolve? To restore the equilibrium, comma, maintaining the value of the equilibrium constant. Are we together? So solubility of aluminum hydroxide increases. Aluminum ions react with nitrate ions to form aluminum nitrate, which is soluble. That word is very important. Concentration of aluminum ions decreases at equilibrium. More aluminum hydroxide dissolves to restore the equilibrium, maintaining the value of the equilibrium constant. So don't set to restore the equilibrium constant, because equilibrium constant does not change. It is the equilibrium that is restored, such that the value of the equilibrium constant is maintained. Now, I have an issue here. Why didn't I say that magnesium ions react with hydroxide ions? Why didn't I say that magnesium ions react with hydroxide ions? Why didn't I say so?
So because magnesium hydroxide is also sparingly soluble in water.
That's one reason. That's one reason. The other reason is the concentration of hydroxide ions is very low. For the ionic product of magnesium hydroxide to exceed its solubility product, these hydroxide ions are very small. That reaction cannot take place. Its concentration is very low to react with the magnesium ions to precipitate magnesium hydroxide. This one is sparingly soluble. It cannot give us enough hydroxyl ion concentration to react with magnesium ions. Do you get that?
Yes, teacher.
So that reaction cannot take place. So that summarizes the factors that affect solubility of sparingly soluble electrolytes.